What if none of this is real? Not in the philosophical sense of questioning whether the external world exists independently of your perception of it. That question is old and has been asked since Descartes sat alone by a fire in 1641 and wondered whether a deceiving demon might be feeding him false experiences of a world that was not there. What has changed in the last 30 years is something more specific and more technically grounded, a new version of that old question, one that does not require a demon or a god or any supernatural machinery at all. What if this universe, the one you are inhabiting right now, with its physics and its history and its 13.8 billion years of apparent existence, is a computational simulation running on hardware built by a civilization more technologically advanced than ours? This is not a question from science fiction. It is a question being taken seriously by physicists, philosophers, and computer scientists at the highest levels of their fields. Elon Musk has said publicly that the odds we are living in base reality are 1 in billions. Neil deGrasse Tyson has said he thinks the probability is high. Oxford philosopher Nick Bostrom published a paper in 2003 that formalized the argument so precisely that it has never been fully refuted, only debated. The argument runs like this. One of three things must be true. Either virtually all civilizations at our level of development go extinct before reaching the technological capability to run detailed simulations of conscious minds, or virtually all civilizations that do reach that capability choose not to run such simulations, for ethical reasons or lack of interest or some other consistent motivation that prevents them from doing it. Or we are almost certainly living in a simulation right now. This is the trilemma Bostrom laid out, and the logic is tight enough that you cannot escape it without committing to one of the three options, and every option is strange. Consider the third option first, because it is the one most people find hardest to dismiss. If even one civilization in the history of the universe has reached the technological capability to run detailed simulations of conscious minds, and if that civilization ran even a modest number of such simulations, then simulated minds would vastly outnumber non-simulated minds. The ratio would be enormous. For every civilization living in base reality, there could be thousands or millions of simulated civilizations, each containing billions of simulated minds, each experiencing their reality as completely and convincingly as you are experiencing yours right now. In a universe where simulations are possible and are run, the statistical likelihood of being in base reality rather than a simulation approaches zero. The only way out of this conclusion is to embrace one of the first two options. Either technological civilizations reliably go extinct before reaching simulation capability, which would require something to be filtering them out, something like the Great Filter from the Fermi paradox, or technological civilizations reliably choose not to run simulations. The second option requires a remarkable and unexplained consistency of choice across every advanced civilization that has ever existed anywhere in the universe. Why would they all make the same choice? What would motivate every civilization capable of simulation to decide independently not to do it? Neither escape is obviously more plausible than the conclusion they are trying to avoid. The physicists' arguments for the simulation hypothesis are where it gets genuinely strange. In 2012, physicists at the University of Washington ran theoretical calculations to test whether the laws of physics, as we understand them, show any signs of being computationally generated. They were looking specifically at the behavior of high-energy cosmic rays, particles arriving from space with energies so extreme that any computational simulation of physics would, at some level of resolution, have to impose a cutoff, a maximum energy beyond which the simulation simply does not model the physics accurately because the computational cost would be too high. This cutoff would appear in the data as a specific directional asymmetry, a pattern in which direction the highest energy cosmic rays arrived from. And there is such an asymmetry. It is called the Greisen-Zatsepin limit. The researchers noted that the pattern of this limit is consistent with what you would expect from a simulation running on a cubic lattice, the most computationally efficient way to model three-dimensional space. This is not proof. The Greisen-Zatsepin limit has other explanations, but the researchers argued that if you were looking for signs that the physics of this universe was computationally constrained, this is what you would look for, and this is what you find. The nature of quantum mechanics has attracted similar attention. The fact that quantum systems exist in superpositions of states and only resolve into definite outcomes when observed or measured, what physicists call the collapse of the wave function, has an uncomfortable resemblance to a rendering optimization. A simulation that only fully computed the state of things when they were being observed would be enormously more efficient than one that maintained the full state of everything at all times. Quantum mechanics looks, to some physicists, like exactly the kind of optimization a programmer would implement to reduce computational load. Max Tegmark, a physicist at MIT, has gone further and argued that the universe is not merely described by mathematics, but is mathematics, that physical reality and mathematical structure are identical, that what we call matter and energy and space-time are ultimately abstract mathematical objects that exist independently of any physical substrate. If Tegmark is right, then the distinction between a simulated universe and a non-simulated universe may not be meaningful. A universe that is fundamentally mathematical is already in some sense a computation. The question of whether it runs on silicon or on some other substrate becomes secondary. The philosopher David Chalmers has approached the simulation hypothesis from a different direction. He argues that even if we are living in a simulation, it does not follow that our experiences are less real, or that our lives are less meaningful. The tables and chairs you interact with are real within the simulation. They have consistent properties, they behave according to laws, they cause and are caused by other things. Reality, Chalmers argues, does not require a particular kind of physical substrate to be genuine. It requires consistency, causation, and the kind of lawful regularity that makes experience coherent. A simulated reality that has all of those things is a reality. It is just a reality running on different hardware than you assumed. This is philosophically careful and genuinely reassuring. It does not resolve the deeper questions. If the simulation can be turned off, if the simulation running it can choose to end it, then everything in it is contingent in a way that base reality presumably is not. The continued existence of everything you've ever known or loved depends on a decision being made by entities you cannot contact, cannot appeal to, and cannot even confirm exist. And if the simulation can be modified, if the programmers can alter the laws of physics, insert events, change outcomes, then the regularity and consistency that Chalmers says makes simulator reality genuine is not guaranteed. It is permitted, which is different. The strongest argument against the simulation hypothesis is not a refutation of its logic. The logic is difficult to refute. The strongest argument is what philosophers call the problem of infinite regress. If we are in a simulation run by a civilization in a universe above us, what is the status of that universe? If simulation is possible, it is presumably possible for that civilization to also be simulated, running inside a simulation inside a simulation. Turtles all the way down with no base reality ever reachable or verifiable. The hypothesis does not so much explain reality as defer the question of what reality ultimately is to a level we cannot access, which is the most honest thing that can be said about it. We don't know what reality ultimately is. We never have. The simulation hypothesis is not a solution to that question. It is a precise and technically grounded version of the same question that Descartes was sitting with in 1641 by his fire, dressed in the language of computation and physics rather than demons and dreams, but pointing at the same darkness. The universe behaves as if it has rules. The rules behave as if they are mathematical. Mathematics behaves as if it exists independently of the minds that discover it. And minds behave as if they are something more than the matter they are made of, or as if the matter they are made of is something stranger than matter has any right to be. Whether any of that points toward a programmer sitting at a terminal somewhere above this universe is a question the evidence does not answer, but it is a question the evidence no longer allows us to dismiss.